Welcome to the next module in the geometry course. We finished angles in the last section, and hopefully you have taken the final little quiz for that chapter and did very well with that. So we are ready to move on to polygons. In your notebook, this is the second tab, polygons, and let's just get right to it. The first thing that I want to do is give you the definition of a polygon. And even before I do that, I want to call your attention to this prefix, poly. This is not the name poly. This is a prefix that means many. So anytime you see the prefix poly, you're talking about many of something. And in geometry, a polygon is a closed, and let's get the definition and then I'll explain the parts to you. It is a closed figure in a plane, and I'm leaving some space so I can go back and add to that. Formed, or that is formed, and it would help if I could spell. I can't talk and write at the same time, so by at least 3 sides. And that part's pretty self-explanatory. So let's break down this definition just a little bit. I want to look at the word closed. And you know that word. We use this word quite often. But in geometry, a closed figure means that there is no open space. And let me just show you down here on this example. We're not going to leave this like this, but let me show you the difference between open and closed. As this triangle is sitting here now, this is closed. But if I were to take a section out of it, and it's not going to let me do that. Let me try this. If I were to take a section out of this figure, so if I were to open a place in there, that is open, okay? So open and closed. So polygons are always closed. There is no space in the shape. If you were thinking of this in practical terms, if this were a garden, it's completely closed in by fencing. There's no gate, there's nothing to open it up. So a closed figure, and plane, right there, change colors again. Plane in geometry is flat. So this is a flat, closed figure that has at least 3 sides. So a circle is not a polygon. It doesn't have sides. And I'm going to show you some different kinds of polygons here. And let's just move right on into that. So let's study this one first. And to help you visualize a little better, I like to put in the vertices points. This is a vertex, and a vertex. Okay. This is a 3-sided figure. That is called a triangle. It has 3 sides. It has 3 angles. So tri means 3. This is a 3-angled polygon. And let me draw in the angles for you. And we learned in the last video that a triangle always has a total of, do you remember how many degrees? 180 degrees. So whatever the measurements of those angles are, they will add up to 180. So a triangle is one type of polygon. Triangle. Okay, in the next section, let me zoom in right here. You know this one, I bet. This is called a square. And a square is one of the most perfect shapes that there is. It has 4 right angles. And so that tells us something about the measurement of a square. So if I mark the 4 right angles, and hopefully you remember what that little marking means. Do you remember what each of these little squares represents? Those are right angles. They're 90 degrees. So 90, 90, 90, and 90. So a square has a total of 360 degrees. And we learned also that a circle has 360 degrees total. So a square is the second one of the shapes that I want to share with you. And let's go ahead and label a square. Usually you're going to see this called the side. So you will have an S as the variable for labeling the side of the square. And all sides are equal. If this is a square, the sides must be exactly equal. Okay, the next shape is this one, and we can draw in our angles again. Always learn to look for these angles where you can find them. And this is 90 degrees again, all around. So 90 degrees, 90 degrees, 90 degrees, and 90 degrees. And I know you're probably tired of hearing me say that. Please bear with me. This is called a rectangle. A rectangle has 4 right angles. And 2 sets of parallel sides. We have 2 long sides and 2 wide sides. Total of 4 sides because we have 4 angles. So let me draw your attention here. This is going to be important in just a little while. When we start using our formulas, this is going to be very important. So this is a long side. I like to call this one the length because it's the longer of the 2. And you have 2 of those. So we could draw tick marks to show that these 2 are congruent. That means exactly the same. And then we also have 2 wide sides, which I like to call the width. So here's one, and here's one. And these 2 sides are equal. So I'm going to use double tick marks to show you that those match up. Single tick, those are equal. Double tick, those are equal. And just so you know, the word I'm saying is tick, T-I-C. So a tick mark is what I've drawn, those little marks to show equality. Okay, this next one, so here's a second shape. I would recommend making some flashcards with these shapes until you learn them. It's a very good way to learn what the names are. And you've learned 3 so far. You've got triangle, square, and rectangle. Let me go back to the triangle just a minute. I want to tell you that there are different types of triangles. I have shown you an isosceles here, but let me just give you the names of them, and if you want to research those on your own, you can. I'm not going to take the time to do that. That would be trigonometry, and the test really doesn't test that specifically. But anyway, you've learned about the right triangle. You've also learned about an isosceles triangle. Okay. You can also have acute triangles where all the angles are less than 90. And you can have obtuse triangles where you have one of the angles in the triangle that's very large, like 120 degrees would be obtuse. Isosceles means 2 sides are equal. Equilateral or equilateral means that all sides are equal. And then scalene means that no sides are equal. Again, I'm not going to belabor this point, but I do want you to know that there are different types of triangles. And just in case you hear those words, those are, at least the bottom 3, those are referring to triangles. Okay, this last guy. This one is a very unusual looking shape, and it has a very unusual name, as you might expect. This is called a trapezoid. And I'm going to move this over just a little because I want to give you the anatomy of a trapezoid. Trapezoid. And a trapezoid has 4 sides. Always 4 sides. And it has 2 parallel bases. And I'll show you what that means. Let's just get the definition down. 2 parallel bases. And that's all I'm going to say there. Let's label this figure. The first thing I want you to do for me is to draw in a line. And let me use a different color. I don't want this to get all confused. So in this trapezoid, I want you to draw in this line. You could also draw it right here. And if you notice what I've done, I've created a rectangle in the middle and 2 triangles on the ends. But really what I'm interested in is this line right here is imaginary. We don't see it. It was not part of the original shape, but I have to view it in my mind's eye because this is the height of the trapezoid. And when we start working with these in formulas, we're going to need to know the height in a lot of our problems. The height is always perpendicular, meaning 90 degrees to the base. So it's not leaning. And I used to tell my class, if you think about going to the doctor and they want to measure your height, they want you to stand up straight. They would never do your height with you leaning. You always want to stand up straight. So height for the trapezoid is this imaginary line in the middle. And it connects one base to the other base. Remember, a trapezoid has 2 bases, and we're going to call this one base 1 and base 2. You could do it the other way. You could say that this is base 1 and base 2. It really doesn't matter. But I know myself, and through the years, I have come to think of them this way. So for not causing confusion, I'm going to stick with that. I don't want to try to change my thinking on this point. And then this one I'm going to refer to as the slant. I'm not sure what the proper name for that is, and I should know that. but for the purposes of this video, we're going to call that the slant. What I want you to realize is that it is not the height. You never measure your height leaning. So height is always straight up from the base. We will use these words a little bit more later on. Let me give you the variables that go with them. This will sometimes be called B1 and B2, base 1 and 2, and then H for height. Okay. All right, you may have noticed that I marked these three shapes before I even began on this. This was printed on there, as a matter of fact, because I want you to know that these shapes have a name. They're in a family of four-sided shapes. And the name for that is quadrilateral. And I'm going to have to lock my screen here if I can figure out how to do that, because I want to turn my tablet to the side without it rotating. And this is called a quadrilateral family. Quad means four. Tri means three. Quad means four. So think of 4 quarters in a dollar, or a quartet has 4 people. So quadrilateral is the family with 4 sides. Square, rectangle, trapezoid, those are all quads because they have 4 sides. And that's why I grouped them in this family. So another definition that you need to know is the definition of quadrilateral. And that whole family is here. And there are others. I've just shown you 3 of them here. I think the next page has another one. So let's go ahead and flip forward. Yes, I'm glad actually that this one is here. This is a parallelogram, and that is a tough word to say. First thing I want you to notice is that it's leaning. It is not standing straight up because it does not have 90-degree angles. Okay, so it is a quadrilateral. It has 4 sides. But it has no right angles. And that's what's causing the leaning. So this angle is acute, and so is this one. This angle would be obtuse. Okay. But you see the 4 angles and they're leaning. None of those angles is a 90. So there's not that perfect corner and that perfect straightness in there. Okay, I want to take those out so I can show you the height of the parallelogram. This is a little bit hard to see sometimes. But remember, we never measure height leaning. So height is always going to be from this base to this one. And that is not very good. Let me try that again. Height is a straight line. I still am not nailing that quite right. My pen's a little too thick, maybe. And that's even worse. Let's try it this way. I'm sorry. I'm trying to get that. I guess that's okay. Height is going to be usually a dotted line. Usually you're going to see that perpendicular symbol down here at the bottom to show you the 90-degree angle. So this is the height of the parallelogram. And we use the variable h for that. This will be called the base of the parallelogram. And we use b for that one. So base and height will be the 2 variables for a parallelogram. Okay. I didn't need that much space for this one. Let me see if I can, well, I probably don't need to try to draw another one. We'll just let it go at that. There will be other examples down the line. Okay, just to make you aware of these shapes here, because occasionally we do run across these names. Let's take a look at this first one. If you do any kind of work in a machine shop, you may know this one. But let's count the sides, and I'm going to put those in with tick marks as we count them. So here is 1, 2, 3, 4, 5, 6 sides. So this is a 6-sided figure. This one is called a hexagon. And the way that I remembered this term was that the word 6 has an X, and so does hexagon. So hexagon is a 6-sided polygon. So any polygon that has 6 sides would be called a hexagon. Okay, let's count the sides on this one. 1, 2, 3, 4, 5, 6, 7, 8. So this one has 8 sides. This is a stop sign. This is a very classic shape that we all see every day almost. This is called an octagon. Octa is 8. Like an octopus has 8 arms. If you play music, you may know that an octave has 8 notes on the piano or on any instrument. An octave is 8. So an octagon is an 8-sided polygon. Okay. So let's count the sides on this one. 1, 2, 3, 4, 5, 6, 7. 7 sides. This one is called a heptagon. Heptagon is 7-sided polygon. And I'm missing one. Do you know which one I'm missing? Let me go into my little sticker book and we'll make a copy of this one and bring it over. I don't want to try to draw it because that's a little bit, sorry, algebra shouldn't be open. Here's one. See if we can get it to paste. Yes, and resize. This one, you may recognize this one if you watch the news a lot, because the Department of Defense in America is in a building that's shaped like this one. And let's count the sides. We have 1, 2, 3, 4, 5. This is a pentagon. Oops. I don't want to put penta there. I want to put 5 there. A 5-sided shape is called a pentagon. And if you've heard about the Pentagon in Washington, D.C., or maybe you've seen it, the best way is to fly over it because then you can see all the sides. It is a 5-sided shape. It's a 5-sided polygon. So a pentagon is the one that I forgot to put in. Not sure how that happened. It's one of my favorite shapes. So there's the 5-sided. And just for your reference, I want you to know, let me rearrange this because I need to tell you one other thing that I haven't thought about here. So let me create a little more space. And I will tell you for 9, the term is nonagon. And I didn't draw one of those. I don't think Microsoft Word has one. But a nonagon, nona is 9. And a decagon, deca is 10. And I'm going to stop there. Although there are others, but I don't think you're going to see any of these, quite honestly. But you might, and if you go on to college, you definitely might. So this is an introduction to the polygon families and their names. Okay, one other thing that I want to tell you is a definition, and I forgot to write it in here, but let me do it. When you see the term regular polygon, or irregular, I guess, would be the opposite of this. A regular polygon has equal sides. So a square is a regular polygon. Its sides are all equal. And all of these that I've shown you are regular except for the parallelogram. All of the purple ones are regular polygons because I drew them in Microsoft Word and it draws them all equally. So if you see the term regular polygon, you can rest assured that that means equal sides. All sides are the same. Okay, I'm going to stop this video and I will see you in the next series for the next section. We're still in the same module, but I'm going to stop and resume in a little while.